So the difference between indefinite and definite, definite we come up with an actual answer. Indefinite will be left with algebra. There's a real subtle difference, you'll notice. There's no numbers to substitute in, so I don't have my square brackets, but I also have this other thing there, plus a constant. There might be a constant. Because remember, when you differentiate a constant, what do you get? So therefore, logically, when you integrate 0, it's quite possible there could have been a constant originally. Now, that didn't matter when we had a definite integral, because when we sub into function A, I'll have all that plus the constant. Sub into function B, I'll have all that plus the constant, and so the constant cancels. So we didn't have to worry about it. But when we're not substituting numbers in, we need to take that into account. There could be, any number. And unless they give me more information, don't know what it is, so I'll leave it as plus a constant. This is sometimes called the useful theorem, because it's useful. Okay? If you've got a linear function to a power, you don't have to expand the whole thing out. You can still just go, add 1 to the power over the power, but on the bottom of the fraction, you also multiply by whatever the coefficient of x is. It saves you expanding the whole thing out. It only works for linear functions. If it's quadratic, well, bad luck, we're stuck. Unless, of course, you can factorise the quadratic into linears, but that's a whole other story. Got to be a linear function to use our useful theorem. So if I get 2 minus 5x to the power of 3, don't have to expand the whole thing out. I can still add 1 to the power over the power, but you'll notice on the bottom of the fraction, I've also multiplied by minus 5, the coefficient of x. It's really useful for something like this. dx over 3x plus 1 all squared. Got to change it to index form. Well, how would I expand 3x plus 1 to the power of negative 2? Well, I can't do it even if I wanted to. But because it is a linear function, I can deal with it. Add 1 to the power over the power, but on the bottom of the fraction, I'm also multiplying by 3. So I don't just get negative 1, I get negative a third. Same if I'm dealing with a square root. Put that in index form. We get 2x plus 1 to the power. Trust me, that is a power. A little bit low, but there you go. Again, how would I expand that out? I mean, I can't. But I can add 1 to the power over the power and then multiply by the 2 on the bottom as well. So I get a third 2x plus 1 to the power of 3 on 2. That's how mere mortals would leave the answer, of course. But us super mathematicians will say, 3 on 2, that's the same as 1.5. So power of 1, square root of 2x plus 1. Okay, so we'll add those few in there.